Let's talk about terminology. We know that the points we identified here are called focus points, and we know that the plural of focus is foci. These two curves are called branches of the hyperbola, and a line that contains the focus points will intersect the branches at 2 points called vertex points. We know the plural of vertex is vertices. Now, a point right in between the 2 vertex points is the center of the hyperbola. Notice that the center and the vertex points and the focus points, all important aspects of the hyperbola, lie along the same horizontal line here. Now, the portion of that line which connects the 2 vertices, that is, this segment between vertices, is called the transverse axis. Sometimes the transverse axis refers to the entire line, but we'll be using this segment as the transverse axis. Well, to understand aspects of the graph, let's consider that the center of the hyperbola is located at the origin of a coordinate plane. The equation that describes the hyperbola is this equation. Notice how closely it looks like it's related to the equation of the ellipse. It has a 1 on the right side of the equation. There are 2 fractions on the left side. The most important difference is this minus sign. Just like the ellipse, the A distance is a distance from the center to vertex points. And the B distance is a distance that's measured perpendicular to the A distance. Remember, with the ellipse, the B distance was along the minor axis, which was perpendicular to the major axis. And here, the B distance is perpendicular to the transverse axis. Well, let's get an idea of how the graph emerges from these A and B distances. First of all, we would want to measure the distance B on the other side of the center. And now what we'll do is we'll form a rectangle using these distances from the center. The rectangle would be formed like this. Now, this is just a reference rectangle. Next, we'll draw lines that contain the opposing corners, opposite corners of this rectangle. And the lines that we're drawing here are going to be asymptotes for drawing the branches of the hyperbola. Now remember, asymptotes have this characteristic that graphs get close to them at the extremes of the coordinate plane. So all we want to do is draw the branches so that they get close to the asymptotes, and the branches need to contain vertex points. So one branch would be on this side containing the vertex and getting close to the asymptotes, and the other branch on the other side. Now, the distance to the focus points can be calculated here, just like we did with the, or very similar to the way that we did with the ellipse. If we call the distance from center to the focus points C, then the relationship between A, B, and C is simply C squared is A squared plus B squared. Notice plus here instead of minus. And this relationship between A, B, and C is exactly the same as is the case with the Pythagorean relationship, so it's particularly easy to recall. Well, when the transverse axis is horizontal, the equation looks like this. When the transverse axis is vertical, the equation takes a somewhat different form, as we might expect. Now let's understand aspects about these two equations compared to one another, and also compared to the equations that look so much like them that described ellipses. Now with the ellipse, we were able to tell aspects of the graph by looking at which of the numbers in the denominators were larger. That is, which of A and B were larger in the denominators. And we could identify A and B by virtue of the larger of the two numbers. Well, here, A squared, notice, appears in both of these first fraction denominators. So A will always appear in the first fraction of the equations of hyperbolas. So we don't have to worry about which one is bigger or smaller, because that'll change from problem to problem with the hyperbolas. Now, there is the same kind of situation occurs between numerator and denominator, though. With this fraction, we notice that this is the equation for a hyperbola that has a horizontal transverse axis, and A and X are horizontal distances. And for the other equation, A and Y lie along a transverse axis that's vertical, and A and Y are both taken as vertical distances. But in both equations, the relationship between A, B, and C is C squared is equal to A squared plus B squared. Well, we need to go through the process of completing